if you click this video at one point of the way, then please tell me what the reason was so that I can improve. Otherwise, hi and welcome. I'm trying to learn space science. Today, Walter Sidney Adams, and after that, Agena, and after that, Sir George Biddle Airy. And after that, body center training. And if you participate in the body center training, then it's at your own risk. And these are just dictionary entries. Walter Sidney Adams, he was born 1876. He was an American astronomer who discovered an important method of measuring the distance of stars from Earth. Okay, we wanted to know. We looked in the night sky and we were wondering how far is that star away, and another one how far away. The method compares the actual brightness of a star, calculated from its spectrum, with its brightness as seen from the Earth. Okay, that's a good way. I have just absolutely no idea how someone calculates the brightness of a star, the actual one we had with the absolute magnitude. So we're going to go now for a moment to spectrum, if we have spectrum. Spectrum, the complete range of wavelengths emitted by an object. That is interesting. The term normally refers only to an object's visible light. Study and classification of the spectra of astronomical objects provide astronomers with much of their knowledge of the universe. I think they did the following, or Walter Sidney Adams. They were looking what light of a spectrum was reaching Earth, and they knew which light would come through, but it doesn't really make sense, all light make it through. And then they knew which one is missing because of the message, because it says so far away. The complete range of wavelengths emitted by an object. The term normally refers only to an object. When was it? 1876. See also distant modulus, magnitude. Let's go there for a moment. Distance modulus? Not really. Let's see it. A way of measuring the distance of stars or galaxies from the Earth. The technique is based on the fact that stars appear less bright with increasing distance from the Earth. Astronomers worked out how bright a star actually is, its absolute magnitude, and compare this with the brightness it assumes in the sky, its apparent magnitude. This difference, the distance modulus, can be used to estimate the star's distance. The absolute magnitude can usually be estimated from the nature of a star's spectrum. Back to spectrum. I think we did the following. I think when they're referring now to the spectrum, they don't mean just light which reaches, or visible light, which is from violet to red. I think now in the 1870s born, lived until 1956. In the 1940s, when he did it, probably they knew already about gamma rays, ultraviolet rays, microwaves, infrawaves, and so on. And that maybe some of these wavelengths don't hit Earth, don't come to Earth. And so we were looking, we're getting the red light, the violet light, and we're getting the ultraviolet light, and we're getting the infrared, I don't know where it's exactly, but we're not getting the microwave light. And so they knew that thing cannot be as far away as microwave light would reach. We're going to do now the presentation, and I'm just going to say what I assume. I'm going to say that is my estimation, what it is, or what is my assumption. Okay, Walter Sidney Adams, born 1876, and he discovered an important method of measuring the distance of stars from the Earth. And it compares the actual brightness of a star, called the absolute magnitude, with the brightness it has on Earth visible, the apparent magnitude. And that is done, and that has it help the spectrum of light which is emitted. The complete range of wavelengths emitted by an object is the complete things of wavelengths which are emitted. There's an explanation, but I'm going to say what I believe. And and when we try to do it. So I'm going to start with the second camera, I just said it. I always think of someone else. Walter Sidney Adams, 1876. Walter Sidney Adams, born in 1876, lived until 1956. He worked out an important method to measure the distance of stars from the Earth. And it was done with comparing the absolute magnitude, how bright the star is actually, and how big the apparent magnitude is of a star on Earth, so how bright it appears on Earth. And that did he do with looking on the spectrum, some things. Now, there's the explanation missing. I think it's the following, that there are different types on the spectrum of the electromagnetic spectrum, and there can be gamma rays or radio waves, and some of them are longer and reaching the Earth. And I think now that the stars emitting just all these different types of light and rays, ultraviolet and microwave and infrared or whatever, and just some of them reach. And by looking, it have reached this, or this rays of light have reached Earth. It was able to say it sounds so far away. But I don't know, it's not explained if it is the case. I don't even know if it is possible to do it that way. But that first part was according to Structure of the Universe of the page 48 of the Reader's Digest, Library of Modern Knowledge, Book 1, Part 1, written by Ian Ridpath and John R. Shakespeare. Where's the camera? And we have the second part here. I don't know if we have time for it. But the second one. Agena. An upper stage rocket. First, an upper stage rocket often used on top of US Atlas and 4 first stage rockets to launch space probes and satellites. Astronauts in the Gemini space missions docked with Agena rockets placed in orbit. Okay, it is an upper stage rocket. Okay, it is a type of rocket. So these rockets of which satellites are flown into space, or people also. It is some type of rocket, and it's the upper stage, just the upper stage of it, or whatever. And it's used on top of US Atlas and 4 first stage rockets to launch space probes and satellites. Now there are the rockets, there's the first stage, and that are US Atlas and 4, and then on top of them is the upper stage rocket, and that is Agena. Maybe there's a third stage, but it's the second stage, or the upper stage. And that whole thing has been used to launch space probes and satellites into the space. Astronauts in the Gemini space missions docked with Agena rockets placed in orbit. A picture would be good. I don't really know what we're talking about. But I think we can understand it. It is a part of a rocket. It's the upper stage part, and at that part the satellite is. The rest is just for the fuel or something. It is a part of a rocket. We are not able to do the presentation with that knowledge, but we having the knowledge. It is a part of a rocket. It is the upper stage. It was used in the lower stage called the US Atlas and 4. Probably was where the fuel in to start the rocket, and that whole thing was also used during the Gemini space missions when people were docking onto rockets in place, or placing rockets in space. Whatever. It is a part of a rocket. We're gonna get some time later a better explanation. Now the last part. Sir George Biddle Airy. Was it the one named here? Yes, the British astronomer Royal Sir George Airy. So he was mentioned in the part about John Couch Adams, and that was said that after John Couch Adams had calculated where the planet Neptune is, based on that the orbit of Saturn is a bit brought to the side, the orbit of Europe, the orbit of Neptune. John Couch Adams, English astronomer who was the first man to calculate the position of the planet Neptune, Since the discovery of the planet Uranus in 1781, it had been realized that its orbit was being disturbed. It's Uranus and Neptune. So Neptune. He calculated that Neptune is based on that Uranus's orbit is a bit distorted by something. And then he just calculated where no Neptune is. But now there was this Sir George Royal Airy who mentioned that he was not fast enough to discover now the planet actually. Not just calculate where it is, but discover it. Someone else did it then. Johann Gottfried Gale. Okay, Sir George Biddle Airy, born 1801. He was an English astronomer. As Astronomer Royal from 1835 until 1881, Airy instituted Greenwich Mean Time as Britain's official time system in 1880. Airy extensively reorganized the Royal Greenwich Observatory and introduced a telescope for measuring time by the stars, which can still be seen at the old Royal Observatory. Because of the observatory's reputation under Airy's guidance, the Greenwich Meridian became in 1884 the world's zero line of longitude upon which time changes throughout the world are based. Okay. He was for 50 years in the United Kingdom the important person in the astronomy branch, and he introduced in his second last year, in one of his last years, as a very important person, the standard time or the official time for Britain, and then also based on all of that, in 1884 also made the longitude with a zero line, set up that basically the time starts there, and people who are an hour forward or backwards have then the time shifted always. But that's too complicated to do that now. We're going to come back in the next part, and then we're going to do then Sir George Biddle again, and try to make then a little presentation about what we have learned or read here about Sir George Biddle Airy. If you were here for space science, you can now directly to the next part of space science. Then we're going to do it. If you stay here and participate in the body center training, then it's better that on this guy. We are having the legs standing hip width apart, and we're going down into the knees. Flex the legs and press them together. Now straighten one leg. Bend it again. Our legs straighten it. Press together legs all the time. Bend again. Up. Wider apart the legs, a bit down and flex and press together. Straighten again one leg. Bend again. Press together legs. The other one. And straighten again. A bit closer and press to the outside. Now, one leg up and press on top against the knee. The right angle with the leg, flex foot, even right hips, taller with the back, a little bend in the elbow. Press from the inside. Press up and to side, and press on the outside. Now slowly. Close it. Other leg up, press on the top. And from the side. And press up and to the side. And press on the outside. Now slowly. Close again. And now, 3 exercises on the ground. First, the start leg on the elbow. And if you can and like, one leg up. And now on the long arm out, leg up, and bring elbow to knee. And over to the other side. One leg up. And now if you like again, on the long arm. Arm out, leg up, and put knee to the knee. And make. One heel onto the ground, pull the toes in, and move the leg from left to right. Our heel onto the ground. Pull the toes in and move the leg from left to right. And bring one leg up. Our one. Take it by the ankles. Straight back. Knee onto the ground. Our one. Legs wide apart, breathing down. And crossing. That was the body center training. I thank you very much, and until next time.